Alright, I'm Mr. Brinsfield and I'm going to be going over some notes on ionic and covalent bonding. The first thing that's important to know is really why do atoms bond in the first place? And the goal of every atom on the periodic table, every single element, is to get a full valence shell so it can become stable. Because atoms are only stable when their valence shell is completely full or completely empty. So if an atom is stable, it will not bond. But if an atom is not full, if that valence shell is not full, it will bond. When atoms of two different elements come together, they're called compounds. So remember, compounds require atoms of two different elements, and the reason why they bond in the first place is to fill their valence shell so that they can become stable. An atom will bond with as many other atoms as it takes to fill its outer shell, so it's not always going to be a 1-to-1 ratio. That's why compounds have formulas. However, once any single atom is full, that atom is done bonding. So once that atom either reaches 8 valence electrons in its outer shell or gives up all of its valence electrons so it has none, that atom will be done bonding. And if you need to continue, we need to bring in another atom of the same element. Alright, there are two types of chemical bonds. The first one is an ionic bond. This occurs between metals and nonmetals. So metals are from the left-hand side of the periodic table, nonmetals are from the right-hand side. You guys should remember the stair step coming down the periodic table. That's what divides our metals from our nonmetals. So once again, ionic bonds. These are bonds formed between metals and nonmetals. And then covalent bonds. These are bonds formed between two nonmetals. So we need two nonmetals, two atoms of elements from the right-hand side of the periodic table. We're going to talk about ionic bonds first. As I said, they exist between a non-metal and a metal atom. When two atoms bond ionically, they're either going to gain or lose electrons. The metal is going to lose electrons, and the non-metal is going to gain. When an atom has gained or lost an electron, it gets a charge, either positive or negative. When an atom has a charge, it is called an ion. All right. Here are the examples of some common ions you're going to find on the periodic table. We're going to be most concerned with group 1 and 2. We're going to skip all of those transition metals in the middle, and we're going to pick back up with group 13, group 14, group 15, group 16, and group 17. Group 18 we're not going to do anything with because those are noble gases. Their valence shells are already full, and they're not going to be doing any bonding because they start off stable. All right, calcium's in group 2. So how many valence electrons does it have? The answer is really simple. All you need to do is you just need to look at the group number. So calcium's going to be in group 2. We know it has 2 valence electrons. If we get over, say, to group 13, 14, 15, 16, 17, there's only one other step you have to do, and I'll show you guys that in a minute. All right, so calcium has 2 valence electrons. It needs to either go up to 8 or down to 0. It's going to be easier for it to lose 2 than for it to gain 6, isn't it? All right, so if it loses 2 electrons, it's going to become positive. Electrons are negatively charged, so each electron you lose gives you 1 positive charge. Calcium is going to lose 2 electrons, so it's going to become positive. In fact, it's going to have a +2 ion. So as you guys can see, you might have to squint a little bit down there. Calcium's got a +2 charge. All right, all the other elements in group 2, those are also going to lose 2 electrons, and they're also going to have a +2 charge. So every single element in group 2 has a +2 charge when it becomes an ion. They're all going to lose 2 electrons. Everything in group 1, it's going to lose 1 electron. Now look all the way over to group 13. Those guys don't become +13, they become +3, and here's why. When you jump across that gap on the periodic table, you want to drop the 1 from out in front of the group number. So elements in group 13 don't have 13 valence electrons, they have 3 valence electrons. Elements in group 14 don't have 14 valence, they have 4. Elements in group 15 don't have 15 valence, they have 5. Elements in group 16 don't have 16 valence, they have 6. Elements in group 17 don't have 17 valence, they have 7. Now I want you guys to pay attention because something happens when we hit group 15. So those start having minus charges, and you'll find out later that those first two in group 14 sometimes have minus charges as well. So once we start getting to 5 valence electrons, it becomes much easier for elements to gain electrons rather than lose them. So it's going to be easier for everything from group 15 to gain 3 electrons than to try and lose 5. Elements in group 16 have 6 valence electrons. Much easier to gain 2 than it's going to be to lose 6. And elements in group 17 are going to gain 1 electron because it's much easier to gain 1 than it is to lose 7. Alright, examples of how to actually go ahead and draw ionic bonding happening. You'll see the directions on the left-hand side of the screen and an example on the right-hand side so you can follow along. Step 1 is to actually write the symbol of each of the atoms. In our case, it's going to be calcium and fluorine. Might help to have a periodic table handy for this, so if you don't already have one out.
Please call the Youth Services Center. Miss Paul, call the Youth Services Center.
So if you don't already have one out, please go ahead and take out a periodic table. Alright? Should have been enough time for that. If not, pause the video. Step 2, we're actually going to draw a cross. We're going to divide our element symbol into quadrants. Going to give us 4 sides. Alright, see the crosses on step 2? Step 3, go back to what we talked about on the last slide. You need to find the number of valence electrons. Calcium starts off in group 2, so it's going to have 2 valence electrons. Fluorine starts off in group 17, so it's going to have 7 valence electrons. Step 4, we're actually going to start adding our electrons. We're going to start with calcium because it's got fewer. Please don't pay attention to the actual bullet point that's starting each line. The non-filled in circles are just bullets. They're not actually electrons. So we start off at the top and we start placing them around clockwise, one at a time. So calcium being in group 2 gets 2 electrons. Fluorine being in group 17 gets 2, 3, 4 electrons. Then we go around again, 5, 6, and 7. That one in red is the last one that we're placing. Alright, now we got to account for all the empty spaces that they have in their valence shell. So calcium should have 6 empty spaces. 2 plus 6 is going to give us our 8. And fluorine should have 1 empty space. It starts off with 7 valence electrons and only has 1 space that's empty, keeping it from having 8. Step 6 is going to move electrons from the metal to the non-metal. So you guys can see the arrow I drew from the electron on calcium to the box on fluorine. This is how you're going to move your electrons around. Remember, in ionic bonds, one atom has to lose electrons, the other atom has to gain. So fluorine's going to be full at this point, but we're not going to be done yet. This is because calcium still has 1 to lose. It can't be stable until its valence shell is either full or empty. So here's what we're going to do. We just bring in another fluorine atom. So we're allowed to use as many atoms as we want to make this work. Our first fluorine atom is done, but calcium still has another electron to give up. So calcium's going to go ahead, it's going to give that electron up to fluorine, and then we're going to be done. That's all you have to do for the drawing. Step 8 is how you write the formula. And all the formula does is it keeps track of how much you've used of each one. We used 1 calcium, so it's Ca1. We used 2 fluorines, so it's F2. All right, our first example is going to be the ionic bonding of sodium and chloride. I'm going to be switching to another program to work this out, so bear with me for just a moment. Our second example is going to be aluminum and oxygen ionically bonded together. All right, ionic bonds have specific properties. First off, they have high melting and boiling points. They are good conductors of electricity, and they're solids at room temperature. So once again, ionic bonds have really strong attractive forces, which makes them have high melting points and makes them solids at room temperature. They're also going to be good conductors of electricity. All right, covalent bonding. Let's start with how to draw them. All right, here's an example of a covalent bond between oxygen and chlorine. Remember, in covalent bonds, we share electrons. All right. Here's an example of phosphorus and sulfur, covalent bonding. All right, here's an example of two fluorine atoms bonded together to form fluorine gas. It's also going to be a covalent bond. All right, remember covalent bonds exist between nonmetals and nonmetals. Some examples would be H2, hydrogen gas, H2O, which is water, nitrogen trioxide, and then CH4, which is methane. Covalent bonds share electrons. Remember, the shared electrons don't belong to either atom, they belong to both. They both get to count shared electrons towards their total of 8 valence. All right, properties of covalent compounds. They have low melting points. They are poor conductors of electricity. And they are a liquid or a gas at room temperature.